Thanks a lot, Simon. Yeah, thanks for having me again. And yeah, let us start. Today I wanted to talk, or not today, in this session, I want to talk about monitoring in WVD and with a solution that is not from Microsoft, but is very similar, or that looks very similar, but there are some difference which can bring you a value add. So let me start. First, with a thanks to the sponsors and a short introduction about me, but I guess it's the same as I had in the session before. But in short, my name is Marcel. I'm working for a consultant company in Germany called sepago, and that is a company for that I built this solution some years ago, and that is what we have adapted for WVD. I think for around 18 months to more specified for that. I'm working in the WVD area or more in the Azure area, and they're focused to WVD and even to Azure Monitor, log analytics, what often are the same name or similar names for the same product in the Microsoft Azure product suite is. So yeah, let me start. It was. That sounds like I'm telling something from the past. Yeah, it was in the past. It was in 2017, and exactly it was in 2017 on the MVP Summit where I finalized my first version of a monitoring solution to monitor end-user computing environment. And in 2017, it was focused to remote desktop services, the classic ones, and to Citrix environment. And I wanted to have a solution which gives me insights into the user sessions, into the processes running of an end-user computing or running in an end-user computing environment. So that should be the difference, not only like a normal or classic monitoring of CPU, memory, free disk space, and so on. That was not what I wanted to cover because there are a lot of good solution in the market. I wanted to have the insight into the sessions, into the processes, which in my opinion is very important to know how application works in an end-user computing environment, or especially in an end-user computing environment. So that was what I wanted to achieve this time, and I had some internal requirements for myself. I wanted to have a solution which is able to store data natively without any compression over the time. So typical monitoring solution works that they compress the metrics, the data after a while. There are some solutions in the market which compress after 7 days, 14 days, or a month, depending on the licensing, the data into hour blocks or 4-hour blocks, which then then you have no longer the ability to go back in time and to dig exactly maybe for 3 weeks at Friday 1 p.m. into the data you want to see. So that is what I wanted to have. So no compression over the time, all the raw data. And I wanted to have a solution only built on platform services. So I wanted to avoid any SQL server, any application server, and so on. That was for me very important because I wanted to care about maintaining a SQL server, which is really not so easy, and I don't want to have a monitoring for the SQL server to get an information when the SQL server run out of space. So that is all the stuff I wanted to avoid. Only having a platform services, and in Azure. So Azure is my cloud I work with. So it should be a monitor, a data container, a data space for a big amount of data, and there is one. And I'm pretty sure you already know it. That is the log analytic that is here in the right space. The log analytic or Azure Monitor, often used, as I mentioned before, with similar names for the same product. That is a kind of big data store which everybody can use to put in tons of data. That is one big advantage. It is cheap. Compared to the amount of data you can upload to a workspace, it is fast and it scales out. So while you pay the Azure service by gigabyte, it scales out. If you put up or upload more gigabyte, then the compute power behind is scaled up in the same way, and you don't have to care about the data, about the number of data you upload. That works for one session host, and it works for 1,500 session hosts as well. And even Microsoft use Azure Monitor, aka Log Analytics, in nearly every solution inside Azure to upload the diagnostic settings for the different solution you have. And even WVD host pool or WVD app group, where you can enable diagnostic loggings, is targeting in the best way a log analytic workspace. So what I built in 2017 was this little single item here that's called the Azure Monitor agent for WVD. Maybe the name is right now no longer so good, while Microsoft released upgraded their solution, their native VM monitoring solution, to even monitor WVD, but that is a name, and that is a piece of software running on each session host. It's really easy to deploy. It runs in a system context, and this agent is able to monitor exactly this metrics, which are so important to monitor an end-user computing environment. Not only standard performance counter, it digs into data like or coming from WMI. I query some APIs, and I query all the processes, the process list inside a virtual machine. And this data is uploaded via HTTPS to your workspace, to your Azure Monitor, your log analytic workspace. And that is even the good thing. Normally, a customer deploy the workspace in their subscription, so no data left their environment. All the data stays in their environment, and you have not to care about data privacy or make some contract with a monitoring provider who computes or who process your data to give you then later a visualization in a public portal. So that is all fine, all covered. No data left your environment. You can choose what monitor workspace you use. Normally your own in your subscription, or if you are a service provider, you can have one workspace for all of your customers. That even works. So there are a lot of metrics which are monitored, and I'm often asked, what is the difference between the native monitoring solution from Microsoft and the sepago's Azure monitoring for WVD solution? And mainly the difference is that we get all the data related to a user. So we know what user are using what processes and what is the impact for each process of each user regarding CPU, memory, IOPS, GPU usage in person for 3D acceleration, GPU memory, and a lot of more data. And even data coming as a performance counter are resolved into users. For example, you have a performance counter for the latency for the user session, but you don't have the username in it. And that is what I calculate back. I monitor even this performance counter, and I can name exactly the user and the session representing by this monitor, by this performance counter. That is a big difference. That is going deep into the session. So, but it fits very good to the Microsoft native solution. That is what I have tried to visualize on the left side. That should represent a Microsoft diagnostic enabled WVD solution, where you have configured the host pool, the app groups, workspaces, and so on to send the diagnostic loggings to an Azure Monitor, to a log analytic workspace, to have all the data about the login process, and to see if something goes wrong, if a user cannot log on while a session host maybe is unhealthy. That is all covered from the diagnostic logs, what we get from Microsoft. And after the user is logged on, our solution monitors all that what the user does with the resources on the session host to have this data in the same, normally in the same workspace, to then work with all data together. And if you compare it from a time perspective, the left is from a user perspective is used a few minutes in the morning when the user log on, and in the evening if the session is disconnected. And for the working day, that is what we then monitor. What we are then monitoring the behavior of the application, latency, and so on. So I have a double slide. Sorry for that. I know that the slides will be shared later. There are some points I have written down what I have explained before, where are the different are. That is, to repeat it again or shortly, that is, it's the depth of monitoring Microsoft has, and we have what means how deep we go into the session. And there are some parameter I mentioned before on the right side, but I think it's better to show it in real. So let me skip all the screenshots. That is then maybe for later. If we share the slides, that is what I want to show you now in real in our environment, where I have access to. So let me open. So that is the subscription I used with Azure Monitor, and let me go to my Log Analytic workspace. It's here, and in the Log Analytic workspace, you have a lot of points. The main important is the workbooks. Workbooks are the visualization of data in Azure Monitor log space. That is what I will show later. And maybe there is a mix, to say it clear, maybe a mix between Azure Monitor for WVD and maybe how to work with monitoring data and how to write custo data. I hope custo queries to show data. But let me go into the WVD Insight. That is what you see if you roll it out from the Microsoft Marketplace. Let me go into this. That is my development branch, which shows some newer visualization. So what you directly see is a view to our environment we run on sepago. So that is a very small environment, but it scales out very good to up to 1,500 session hosts. That is the highest number I have seen, and 15,000 users as well. So that's not a problem of the number of users, but let me show it in this smaller environment. What you directly can see is a state of the different host pool we have. We have 3 host pools running right now, and our main host pool, that is a sepago desktop, it contains currently now on 3 active session hosts. There are 7 active sessions, and right now 25 disconnected sessions. So maybe it's close after afternoon, and maybe my colleagues are mainly in at lunch. So, and the load of the host pool, and that is the metric I calculated based on CPU and memory, is around 40.5%. So that is what you can directly see, all your host pools in a row with some key metrics like sessions and active session hosts, running session hosts. Then you can dig deeper into the data by selecting a time range. For example, you can select the last 3 days, that is default, but you can take a look to the last 15 minutes or to the last 90 days or any custom value. And the custom value are usable to, for example, to select last Friday between 1 p.m. and 2 p.m. Then you will see exactly this data from this time frame natively in raw format without any compression. So let me start with the last 3 days. I select one host pool. I select the main host pool, and then optionally you can select maybe a single session host if you want to do that, but that is completely optional. Or you can select a single user if you want to see only data from one or more user. So that is more to drill down. I would go for the last 3 days and the view for the full host pool. Here on the tab, you can select a different perspective from the data. So let me start with sessions. And sessions shows you that what you expect, the numbers of active session, disconnected session over the last 3 days by numbers. That's an interesting number. Maybe some sessions failed. I think that is not so interesting. More interesting is to see the session itself. So you can see that different colleagues of mine had different sessions in the last 3 days. Let me start, or let me figure if I can find myself. So in the last 3 days, I had 1 session on the host pool with a total session runtime of 2.13 days. So I loved my session running over the nights. So that is the reason why the session time is so high. And if you had more sessions, more Unix sessions for the last 3 days or for the time frame you have selected, then you would see some parameter like average session lengths, shortest, longest, and so on. I think more important is the value time to desktop. That is exactly the time which is needed when the user attached to the session host and to the time the desktop is viewed, is visible. So in this example, it was 15.25 seconds, which is a little bit slow. And for my user, I have FSLog for sure, and I have 28 gigabytes free in my FSLog profile, so that is fine. So I don't have to care about that. It could be other if it only maybe 1 gigabyte, then you have to do you have to manage that. And there are some cool scripts in the community to work with the FSLogic's profile disk to free up some memories. So let me click on this. Then I get more detailed data of this session, and this session runs on a single session host. It has a session ID, an internal ID, which is used or can be used to identify a session through the full runtime, and some information when the session started, when the end, or if it's still running right now, then there's no end time. That is right now. And what I get if I click on that to show the last drill down for this kind of data, then I get information about the logon process. And what I can see is mostly important, the load or the attach of the FSLogic's profile disk, which takes 5.3 seconds in this case. And I can see a lot of other data like group policy processing and how long does the different parts of the group policy processing last. So you can figure out exactly what is maybe or what is causing a high delay in the logon process for a single user. What I often see is that this is very high, that is run, that is from a legacy world. If you have logon scripts, and the most people have logon scripts already, then you can see the runtime of the logon scripts. That is often what I see if I have to figure out why a session connect takes long. That is often the reason for that. So then let us see some other data. We have, let me scroll a little bit more down. We can see, and that is now on a per user level. On a per user level, I can see what is the output bandwidth of the users. So my user had an output bandwidth in average that was only 2.6 kilobits per second. And another important parameter is the latency, and the latency in average for all of my session was around 21 milliseconds, which is very good in my opinion. So that is all fine, but keep in mind what you're seeing here, that are averages for the user over the last 3 days, but only if the user was connected to the session. That is clear. That must be kept in mind. But you could have some spikes for some users having a higher latency or a higher output bandwidth which you want to see, and that is what we can see. And for that, I defined an SLA for me, which should show me if one or more users have a higher latency than 200 milliseconds over a time of 3 minutes. And that is what I exactly can see here. My colleague here, Marius, he had the 7 times in a row a higher latency than 200 milliseconds. Then I can click my colleague to then show a line chart, which show me the data for the bandwidth and even for the latency in detail. And so that was mostly fine. Here's some, and here is a higher peak. That is what caused, or this what caused this alert. So in this case, this was only a short time, so that is fine for me. If you would see this over a longer time, then I'm pretty sure there's an issue with the network connection, mostly from the user side. So that's to the sessions. What we have as well is a view to the session hosts. And this is now showing a lot of data about the session host itself, all session hosts in the host pool. So I get some data like minimum CPU usage, which is very low, an average usage of the CPU, and the maximum. Okay, maximum was 100. I guess there was a few seconds some application using a lot of CPU resources, but on average, that is, I think that is fine. 25%, that is good enough, I guess. Even if I go and check the free memory, so on average, the free memory was 20 gigs. So that is, I think here is no problem. And the minimum free memory was 16 gigabytes. So that is even not a problem. So that is all fine. And then I can scroll more down, and here I can see this donut chart that is like the latency that shows me if there was a CPU spike, and there was a CPU spike higher than 90% over 3 minutes. That is what we have seen here, 100%. And I can click this, and hopefully I will deliver this, trust me. And next week you will see what application to what time have caused this CPU spike to identify maybe an application running wild. And then you can decide if it was this fine while the time frame was very short, or is it an application which often raise up to a higher CPU usage. So another views for the logon timing and the Azure resource type using. Let me skip the next one. I think more important are the core metrics. Core metrics are CPU, memory, IOPS, and some queues we have inside an operating system. And let me start with the CPU usage. That is, like you expect, that is a chart for showing the CPU usage for the different session hosts in the host pool, and that are the top virtual machines, the top session hosts having the highest CPU usage, so that you can check what is going, what is working right now. And here's one virtual machine running much higher than all the other. So that is something I will to dig in to find out what happens here in this time frame. And now on the opposite side, the other machine is going up to 86%. So that is what we can see later in the view from the user. What application caused a high usage of CPU. On the other hand, on the right side, that is a 3 megabyte from the RAM perspective. So that is all fine, but you can see that it's interesting. I know that our internal IT reboots the session host each Sunday morning, and that must be exactly this point or close before. And then you can see down where the memory goes down from day to day for the most session hosts. If you see this over 7 days, then I would check if you may have an application having some memory issues, not freeing up memory. More important from the end user computing perspective are the processor queue lengths. Processor queue lengths, and I try to write here some sentences how to, or what does this values you will see here means. And in this case, the processor queue lengths, for example, that should normally around 1.5 and not higher. If you have it higher, then you have an issue regarding application using or making too much context switches, and that could cause by application or that could cause more by too much users on a session host with some application, and that could be a trigger if you have it over all session hosts to maybe narrow down the user density for a session host, or to go for a higher VM size with more cores on board. But in this case, that is only one virtual machine, and I'm pretty sure we will see this later, this application causing exactly this. So I think the other are fine, and only one session host is running wild. That is interesting. Every time I do this demonstration, it looks completely different. Another important point is the disk queue length. This should even be around 1. And this is okay here. It's mostly 1 or less. there are only a few peaks going higher than 1, but that is fine. But if you see that you have mostly the time the lines are around 1 or higher, then this is a good trigger to go from maybe from a standard SSD disk type to a premium SSD disk type. Then this is an issue you have in your environment, that the disk and the IOPS are not fast enough to provide the user with the data. Let me go back to top. Another view is to processes, and that is what you expect. That is a view to the processes running running in the session host over all users, over all session hosts. And this helps me to figure out what application we have consuming in average or maximum the most of our CPU. In this case, this is web-fold executable and some setups and some other part that helps me to get an idea what are the most consuming application, and from the CPU perspective and even from a memory perspective. Let me skip this. This is the same view that shows the application usage based on the memory. So that is what we have here. And here I can see our main application. That is what we use at sepago. That is our CRM system. That is what we use mainly to do the CRM stuff we have to do. And next, this Outlook, what is one of the other application using memory. And that is what we can see from the CPU memory perspective. If I had, and I will maybe show this later, a GPU-enabled virtual machine, then I would also see data about the GPU consumption from the application perspective. I'm pretty sure that Thomas Poppelgaard in the next session will go deeper into this GPU monitoring. So attend Thomas' session to see what happens right with the GPU usage from in WVD environments and how to measure it. The last tab is from an application and user perspective. Here are the most system processes are filtered out, so that we mainly should see real application like OneDrive, our CRM system, and other application running in our environment. Here at this chart, you can see how many distinct users are using different application. For example, OneDrive is used in the last 3 days from 34 different users, and maybe another point, Outlook was only used in the last 3 days by 7 users. That makes sense in our environment because this environment is mainly used for our CRM system. So another view is, and that is, I think, very interesting. What I have done here is I summarized all the CPU usage over all session hosts and over all user sessions over the time. And that gives me a synthetic value, which shows on the top the application using the most CPU on the left or the most memory on the right. And not only in peaks, it includes the runtime and the different sessions a user run, for example, Internet Explorer or Rike, and that our top application, Internet Explorer, maybe not while it is used extremely, but while it is maybe used from all users. So that is the difference here. So if every user used a special application, then this application will have a higher impact to this value instead of an application only used by one user, but having a higher CPU usage. So that can help me to figure out the most used application with the highest impact to CPU and memory. And that is the same values. Then, and in this case, I've filtered this down to a user. And for example, if you check my values shows that I used Chrome, or that Chrome for me of all my session I had in the last 3 days had the most impact to CPU. A complete other value, but very interesting value, is the user input delay. Maybe you know it. User input delay comes from a performance counter giving you the response time of an application to your user input. So if you click and the application registers the click, then it responds, and that is a time from the response. And normally that is in microseconds, so it's very fast. And I have to name it, that doesn't include the network. That is like you work with an application on your local notebook. That is a response time. And if the response time goes up to milliseconds or to seconds, then the user will feel that an application is responding very slow. And that could have different reasons. Mostly that is like here, our application, our CRM application, that is communicating with the backend in our data center over the VPN connection, and that is sometimes slower, and that makes that the application feels and responds slower to the user. So that is a value which should be kept in mind to figure out if there is an application, and then I would dig deeper into that application and figure out what are the dependencies for the application. And if you see really high values, then that is what the user see if the application froze. So if it's grayed out, that is what a user then see if the delay is too high. And I have this on an application level and even on an application and user level. So that is what I can see there. So my slowest application was our CRM system in this case. It responds one time with 3 seconds. So it was really slow, but in average, that's pretty fast. It's in microseconds or milliseconds. So applications are really important. That is what we can see here. That is the application list of the application running in the environment. And they are sorted by the CPU usage in average and in P95. That is what I have to explain later. That is what I have to explain later. Okay, so this shows me the application, is it filtered correctly, with the highest impact regarding CPU. And for example, Internet Explorer, Excel, whatever, have an impact of 13.4% of the CPU usage of all sessions, and it is used by 5 distinct users. And what do I have as well? Some other applications, but let me go for the Internet Explorer. So I can click it, and after that, a next list open, and then I can see the different users used Internet Explorer. So the 5 users are listed here with their individual CPU usage, and that is what I can use to then drill down to figure out in which user session the problem occurs. And if I click on the application and on the user, then I get a chart directly for this application in the session of my colleague, which running around 40% CPU usage, which is I guess much higher, even for Internet Explorer. So, and finally, what we can see here is the number or the crashed application and the number how often this application crashed. And that is really true. In the last 3 days, our application Reich was crashed more than 1,230 times. And I know why. That is because there is an auto update mechanism which fails while the users don't have the administrative privilege to update an application for all users, which is normally common. So that is not really expected, but I'm not wondering about that because we had this in the past. So we have to update the application, and maybe if we figure out how to do that, to configure the application so that the user cannot initiate an update of this application. So the good thing is all the data here, all the visualization here are based on this Custo query. I will later show 1 or 2 Custo query because it's pretty awesome to build own queries and to dig more into the data, like you can do it here with a pre-built visualization. But if you have built a Custo query to show more data or other data, you can completely modify this workbook, because all the workbooks in Azure are open. That is no closed source. You can click on edit and maybe remove a visualization, add a visualization, or remove, add, delete a visualization. So that is what you can do Or if you start building our own dashboards and so on, you can use it to get an idea how I build the queries for that. So that is what you can do. Let me click on edit, and this shows you then the underneath custom query, which show me then exactly this data. So that is pretty easy to modify and to work with, and could give you a good start at building more customized visualization. Another important thing is all data you have here in the log analytic workspace, you can do it with a custom query language. And if after that you can build workbooks, or you can connect Power BI to that log analytic workspace to show or to provide other members in your company with data about the overall performance of the session host, of the application, and so on. So that is pretty easy to do. Let me go to logs. Logs are showing the data like a table. It's called log type. And under custom logs, you have a lot of different log types or tables which start with ITPC. So that are the data which are coming from our agent. And let me show you, for example, one example. If you click on it and run it, then you get all the data for the last 24 hours. And that works pretty fast, even if you summarize data or work with the data. So I get some data back. Let me select once, and then you can see exactly how the data schema is built. In this case, we have the application SVC host Excel running on this worker. And this application has an impact to memory and CPU. That is all what we have here in working set. That is the memory usage. And we have the percent processor time, in this case 0. So that is what we have. A lot of data. And I have prepared a few queries to show you how, in my opinion, cool Azure Monitor works. Log Analytics, I have a prepared demo. So these are different custom queries. I can run them one by one, but let me first select another time range. So 24 hours is nice for the last data, but if you want to dig into data, maybe from the last month or later years, to figure out how was the or how does application works over the time from release to release and with more user, then it can be important to have a wide view to your data. So let me select maybe the last year, February 25. So that are data over 1 year. And then I can show you, I have different, or you have seen it, different tables here. That is from the session host, from the session itself, regarding the processes, performance data, and a lot of more data. And the data regarding the performance data for the last 2 years, let me query this. I will count it to show how many data are in. And this often is very, very fast. And this was fast. So for the last year, I collected for this environment, I have shown you 151 million data sets. So that is a high number of data. And at the same time, regarding processes, and I have one data set each minute for each process of each user on each session host. And that should be a little bit more. And let it count the number of data set regarding the processes. Here's the time, 21 seconds. And that is not cached, it comes directly from the API. So I had collected 781 million data set regarding processes. And then you can work with the data in different ways. Let me skip some information or some queries. I have one cool query, in my opinion. That is a query that summarizes for the 781 million data sets. It summarizes all the data where a username is in, that means the username is in, so that is to avoid having system processes in. And I want to summarize the percentage processor time by user. And then I want to have the top 10 users with the sum of the CPU usage in a pie chart. And let's start. And that is often impressive how fast this is. So it works now with the 781 million data. It's filtered, it's summarized, it's ordered, and then it uses the top 10. And then you can see the different users. And that is very interesting because we have some users having a much higher impact to the CPU than other users. That is sometimes really, really, expressive, I think. And then what you can do, you can go down. Let me do that for my user to not showing all the data from my colleagues. And if I now take the same data set and filter to my user and summarize the same data sets, but by application, then it shows the application I used in the last 360 days in an order based on the CPU usage the application had. And that is this. So you can see work for all our CM system. Is that what I mainly use? And if I don't use it, I go for Chrome, and do internet stuff. So that is where I use environment for. So let me show you one other thing. What I have done, or what I do, the agent I have is installed locally here on my notebook. That is good because it can show you some GPU data. Let me open this workspace. So this is another workspace, not the one I showed you before. And I have two host pools. That is for my presentation from today, from this morning. And here's one unknown host pool, and that is unknown because it's my notebook. So let me select it, go for the processes. And then I see the processes running on my notebook while I'm doing this demonstration and the days before. Here are the applications with the most heaviest impact, like Smart Screen. And then let me go down. I have a grid card inside my notebook. So that shows me data about what application is using the GPU I have built in. And that is even important to know in a WVD environment. Because, or it's good to know, and I'm sure the most know it, Windows 10 used every time it renders something on the screen, it uses GPU performance if you have a GPU card, and if not, it will do it in CPU. So it's always good to have GPU, maybe not the expensive NVIDIA ones, but maybe the AMD ones, which can give you more performance for the rendering so that you have more CPU performance left for your application. And that causes, at the end of the day, that you can have higher numbers of higher user density on the session host. And that is here, for example, Chrome. And I started Chrome today with some 3D animations to force it. And then if I click on this, you can see, okay, here was Chrome using a high number of GPU resources. And even right now, it's used GPU as well. And you have the same for the memory usage. For the GPU memory usage. CPU usage, that was a memory usage. So let me go to this one. Where do I have? I had used Zoom. And pretty sure I have used Chrome, which should show you another line chart on the bottom. And if not, you will see it next Wednesday at least. So that is what you can do with GPU as well. Maybe one, and again, let me repeat it. Follow the next session from Thomas Poppelgaard about AMD and GPU usage. Then you will completely understand what I tried to explain at this part. So how to start with Azure Monitor for WVD from sepago? The easiest way is to install it, and you can install it pretty easy from loganalytics.sepago.com. There are all the binaries, and there are also a link to an installation which gives you the workbooks you have seen, and you can, in the easiest way, you can install it from the marketplace. Into your subscription, that is this one for WVD. Then this rolls out the Log Analytic workspace, including the workbooks, and you can maybe update or next week for the new workbooks with this link that is also in here, workbook installation, that gives you always a newest implementation of the workbooks showing the data. So that is an easy way. And even, yeah, you need, for sure, you need the agent. The agent is downloadable here, or that is much easier. You can go for WVD admin, and if you have session hosts, existing session host, and you want to monitor this session host, then you can select all the session hosts, select sepago Azure Monitor for WVD, run script, and then you can select the Log Analytic workspace, and you can optionally enter a license key. A license key suppress a splash screen. I have a free license key at the end of my slides so that you can test it in a production environment without disturbing the user for months. And that is all. That takes a while. And after that, the data are collected or sent, not collected, sent to the Log Analytic workspace. Keep in mind that you prior configure the diagnostic settings to your workspace. That is mandatory. That is then used by the Azure monitoring agent from sepago as well. So let me check the time, 3 minutes left. And let me go back to my slides. No, so much more in. That are the links so that you can read it after the presentation as well. And really important, and that is a point where I'm very proud of, the solution is also integrated in the Node Manager for WVD. So if you go for the Node Manager for WVD, then you can easily roll out your session host, including our solution. So that is built in. That is a really good way to test it if you go if you have already Node Manager, and if not, you can roll it out with WVD admin, or you can install it. And that is a good thing. You can install it in a golden image on a golden master, which you can use for a golden image, including in the key to suppress the splash screen for the user. And then you can roll out the session host based on the image, and that includes the monitoring for each session host. So I guess I come to the end with my last slide, and I hope you enjoyed the session. And yeah, let me know if it's a valuable solution for you, or if you use it and you want to see maybe other data which are maybe not visualized in the way you want to see it. Let me know. I have so much fun building custom queries and visualization. You can't believe. I would be happy to help and to support you. So thanks a lot, and enjoy the rest of the day.